Okay, so hi everybody. We're going to be using Hess's Law, which is at the end of your notes, at the back of the very last couple pages of your notes. And Hess's Law is a process of being able to add up a series of reactions that adds to an overall reaction. And we're going to show you how a series of reactions can add to an overall reaction and how that can help us determine the overall heat of a overall reaction. And the reason we're able to do this is because enthalpy is a state function. That means it doesn't depend on the pathway as long as it comes out with the overall reaction. We're going to keep in mind the following tips. We're going to figure out how to rearrange the equation so their sum matches the overall equation. If we multiply an equation by a coefficient, then the H value will be multiplied as well. And if you reverse an equation, then you have to reverse the sign. So let's take a look at our example first here of this example here. And so I have in the overall reaction, I have some carbon, and I have some hydrogen, and I have some C2H2. And so I'm looking for those things in my steps. And I can see that I have some carbon, I have some hydrogen, and I have some C2H2. There they all are. Okay. And it kind of bothers me that I didn't use the right symbols. So we're going to go back and use the right symbols. So I had the carbon, which was more of a circle, and the hydrogen, which was more of a square, and then the ellipse or the oval for the C2H2. Okay, so the first thing I'm noticing is that the carbon is going to need to be multiplied by 2 because of that coefficient right there. So I'm going to multiply the carbon by 2. That means the oxygen also has to be multiplied by 2, as does the carbon dioxide. And that means the delta H would also need to be multiplied by 2, giving me negative 188.2 kilojoules. Okay, and then I'm recognizing that the H is not supposed to have a 2 in front of it, so I'm going to have to multiply the equation for the hydrogen by 1/2. So that's going to give me those coefficients. So I'm going to end up having to multiply this by 1/2 as well. And I think that gives me negative 67.4. Now, I just did that in my head, everybody, so you definitely should check my work. I think I'm right, though. I think it's negative 67.4 kilojoules. And then the last one is I'm going to have to reverse this equation because I can see right now the C2H2 is on the opposite side. In other words, it's a product in the overall reaction. So that means that I'm going to literally take and rewrite my equation so the products are on the reactant side and then the reactants are on the product side. So I end up with this. And that means that this reaction, I'm going to cross it out for my own sanity, but that means that this reaction has to get multiplied by negative 1. So I'm going to come out with a positive 311.1 kilojoules. Okay, so let's just check and see how does all of this come out to the overall reaction. And so when I'm looking at this overall reaction, I'm going to want to see what cancels out. So when I've done this, I can see that my carbon dioxide is actually something that does not cancel out. It ends up, it actually does cancel out because I have a carbon dioxide on the reactant and a carbon dioxide on the product, and they both have a 2 in front of them, so they cancel out. I do also have some oxygen that cancels out because I have 2.5 oxygens, which is 3/2 oxygen, and I end up, sorry, that's 5/2 oxygen, 2.5 oxygens. So I am actually ending up with crossing out my 2.5 oxygens with the 5/2 oxygens. And then I have my water, which has to be canceled out. And it does turn out that I have 1 water and 1 water that can be canceled out. So in the end, what I'm left with is my C2H2, which is right here, my H2, which becomes 1 right there, and 2. So that does come out to the overall equation. And then what I have to do is add all this up. So I'm going to add negative 188.2 plus negative 67.4 plus 311.1. And so my overall reaction, I sure hope I did that math right. And no, it does not look like I did. Let's try it again. Negative 188.2 minus 67.4 plus 311.1. 0.1. And I'm coming out with my overall heat of the reaction will be 55.5 kilojoules. Thank goodness I finally got through that one. So let's go see if we can try one more to see what that looks like before you need to get started on your practice problems and your laboratory. Okay, so let's look at this problem here. Enthalpy changes of 3 reactions are given below, and what we want to do is figure out what is the enthalpy change for the overall reaction. And so the first thing I'm going to go do is I'm going to start marking up my page so I can figure out. I am looking at some HCOOH, some C2H5OH, and then on the product side some HCOO, C2H5, and some water. So there they all are. So the first thing I'm looking at is HCOOH. I can see that that is right here, but it has a 2 in front of it. So I'm going to need to multiply everything in this equation by 2. So doing that, that makes this be a 1. So not multiply by 2, multiply by 1/2. That means a 1/2 O2. That makes this a 1, and that makes this a 1. And that means my A is going to be having to multiply by 1/2. Okay, so then I go look for my C2H5OH, and that is also on the reactant side, and its coefficient is 1, just like it should be. So I'm going to leave this equation just as it is. Then I go look for my HCOOHC2H5, and I find that right here, and it's on the reactant side when it should be on the product side. So I'm going to rewrite this, but I'm also going to have to multiply this whole equation by 1/2 in addition to reversing it. So I'm also going to have to change the sign of this as well. So let me go do the 1/2 multiplication first. So that's a 1. That ends up being 7/2, which is same thing as 3.5. That ends up being a 3, and that ends up being a 3. And then I'm going to reverse the whole thing. So reversing the whole thing means I have 3H2O plus 3CO2 yield HCOOC2H5 and 7/2 O2. Okay, so that means that this whole equation is gone now that I have rewritten it, and now all I have to do is start canceling things out so I can see that I have actually gotten to the correct overall reaction. So the first thing I'm going to do is see if my oxygens will cancel out, and we said that 7/2 is the same as 3.5, and so those do cancel out. So yay, the oxygen's gone. And then the next thing I need to do is check and see if my CO2 cancels out. I have 1 plus 2, so 3 over here and 3 here, so my CO2s actually cancel out. And then I need to check my water. And over here I have 1 plus 3, or 4 waters over here, but 3 waters over here. So the 3 waters and the 3 waters cancel out, leaving me 1 water, and that's good because I have 1 water over here. And so I check and see what I have left, and everything left is what we have in our balanced equation. So my overall delta H, I'm going to add all this up. I'm going to have A plus B plus a negative C over 2. And do we have anything that matches that? And I have A plus B plus, and then we should be picking D for our correct answer there. Woo, that was a good one. All right, everybody, thank you very much.